Konnichiwa, watashi wa asan desu. Arigatou, arigatou. 私のプレゼンは Prometheus Exposition Format の未来です。私は Grafana Labs のソフトエンジニアです。Prometheus Maintainer, OpenTelemetry-Collector, Approver と LFX と Google Summer of Code Mentor です。Oh my God, that was harder than I expected. Okay, thank you, thank you. So before we jump into the future of the exposition format, let's talk a bit about what is an exposition format. When Prometheus goes to an application to scrape to collect metrics, the application exposes the metrics in a HTTP endpoint. Usually it's called a /metrics. There is a very specific format that the data needs to be shown so Prometheus can understand what the metrics is about, and it will transform the metrics to the TSDB format, the database. Prometheus accepts more than one exposition format, and the way it controls the collection is through HTTP headers. It's called accept HTTP header. So if the Prometheus says to the application, hey, I accept OpenMetrics format, the application needs to expose metrics in the OpenMetrics exposition format. If Prometheus says, I accept Prometheus text format or Prometheus protobuf or whatever other exposition format, the application needs to understand this accept header and will present the metrics in the appropriate format. You can control your this content negotiation in the configuration file of Prometheus. There is in the global scope, there is one configuration option called scrape protocols, and you put the protocol name in the order that you want Prometheus to respect. But you can also override by target, so you can tell that one specific target you choose another format. And that's done in the scrape config in the particular scrape protocol. Sorry, the particular scrape configuration. Let's talk a bit about the past. So if you use, let me ask you a question. Have you used Prometheus before 2.0? One guy. But did you know that Prometheus used to accept JSON? Yeah. Oh, really? Wow. You are older school than I am. I didn't know that. Yeah, so Prometheus in the past accepted JSON. JSON is a very common format. It's not the most efficient. It's also not the most human readable, but it's a standard. So that's how Prometheus started. It quickly switched to protobuf, which is not human readable at all, but is super efficient for machines. So it made the scrape super fast. But fun fact, not so fun actually, the protobuf scraper in Prometheus had a bug, and the text format was actually more efficient than protobuf, even though protobuf was designed for efficiency. The text format is more human readable, so you can easily understand what the metrics are about. You can understand what the metadata is about, the type of the metric, the description in the help text, metadata. So the text format was not only easier for engineers to understand and to debug applications, it was also more efficient because of a bug that we had in protobuf, and that's what made Prometheus so popular. It was like, once Prometheus designed this text format, Prometheus quickly got a huge amount of exporters because it was just so easy to implement them. We then officialized in this protocol with a name. We call this Prometheus Exposition Format version 004. And then not we because I'm kind of newer, but the team back then, they tried to make the Prometheus Exposition format popular even outside of Prometheus. So the team tried to officialize the format in the Internet Engineering Task Force. And we tried to, I'm giving up. I'm gonna say we all the time. We tried to make this popular outside of Prometheus. So to make this possible, we had to implement a few new features that were not present in the previous version. We tried to make it as close as possible to the previous format, but we had to break some things. We had to introduce some breaking changes. And eventually, we agreed on a format, and we called OpenMetrics 1.0. Once we got the specification ready, we proposed that OpenMetrics becomes a CNCF project. I think it was 2018, I think, it's when it became a CNCF project. After OpenMetrics became a CNCF project, Prometheus also committed 100% to this new organization. Prometheus said, I'm stopping all development in the old version, and I'm committing 100% to OpenMetrics. But once we got to implement, we noticed that those small breaking changes were not that small, actually. I'm going to explain why. Small break. So if you are familiar with Prometheus Exposition format, this is very, very similar. There are a few things that look different. More specifically, when you have a metric, for example, HTTP requests, OpenMetrics has a new feature called created timestamps. The created timestamps represents the time where a time series was created for the first time, and it's super, super useful to make very accurate rate and increase calculations. And when Prometheus scrapes a target for the first time, we get a metric, but we need at least 2 data points to tell how much it is increasing over time. So if we have the created timestamp where a time series was created, and then the first data point that was scraped, we can, from the first scrape, already tell how fast a metric is increasing. So this is one new feature from OpenMetrics. Another, I wouldn't call it feature, but a new requirement from OpenMetrics is that all metrics, depending on the metric type, they need new suffixes. So if you look at the metric name on the metadata, you see HTTP requests, but the time series, there's HTTP requests underline total. These are suffixes that were optional in the past, but they became a requirement for the new format. Well, those 2 new features look very simple, but once we get to the implementation, it's not that easy as it looks initially. So I don't expect you to understand everything here. This is what a struct looks like for an OpenMetrics parser. You can see that we have a lot of fields in the parser, a lot of arrays, and this is what is used in the Prometheus code to, when we scrape a metrics endpoint, we get the whole string, and we send it to the parser, and the parser will transform the whole string in the Prometheus internal representation. The way it reads is by calling that function at the left. It's called next. When we call the parser, I usually call p.next, it will read the one whole line, and we advance the position of the parser to the end of the line. Once I advance the position of the parser, I can never go back. So I read line by line, and I can never read what I already read in the past. So let's simulate what the parser is doing when it's reading OpenMetrics. So I start at the beginning, and I create a new parser by, let's say, calling it p. P is equals to a new OpenMetrics parser. And then I call p.next. and p.next will read the whole line, and it will tell me what kind of line that is. For the first line, it will tell me that it is a type metadata, and if by understanding that it's a type metadata, I can call p.type, and it will tell me the type, which is, in this example, it is counter. If I call p.next again, I'll read the next line. It will tell me that it's a help metadata, and if I call p.help, I get the text from the metadata. Calling p.next again, I will understand that the next line is a time series, and if I call p.series, I will get the label set, I will get the timestamp of the scrape, and I'll also get the value of the time series, which is, in this case, is 100. If I call p.next again, read the next line. If I call p.next again, I'll get another time series, but this time the metric name is changing. So I know that the previous metadata doesn't apply anymore. I just discard whatever I had. So what happens if I have a created timestamp there? So if you look on how it's represented, it looks very, very similar to a time series. So how do I know if it's a created timestamp or if it's a regular time series? If I call parser.next on this line, it will tell me it is, the old code of Prometheus will tell it it's a time series. So this is not really what I wanted. I want to understand that this is a created timestamp. But if I'm at the previous line and I call p.next, I know that I'm reading the next line and I cannot go back. So to understand that this is a created timestamp instead of a time series, I need to read the next line. I need to know that the metric name, HTTP request, is the same name of the previous line. And I need to know that the suffix is underscore created. So how do I do that without breaking the whole thing? Because I'm comparing data that is in the next line with the previous line. So what I do is I create a new parser with, let's call it new p. And new p is created with a deep copy of the state of the old parser. Then I call new p.next, and I see that it's a time series, it's an entry series. And I call the new p.created timestamp function. The created timestamp will compare the metric name with the metric name of the old parser. It will compare the suffixes, and if it's all true, I'm telling this is a created timestamp, and I can ingest as the created timestamp properly. If the created timestamp is not there, the new parser will compare HTTP request in flight, which is not equal to the metric name of the previous line. And then I say, this is not a created timestamp, please ignore. So the old parser is still in the previous position. The new parser is in the next line. So this works. But copying this giant object, let me find it. Copying this giant object all for every line that I read is super, super expensive. Very, very not efficient. It's not the best English, but you got it. And in reality, we see that the OpenMetrics parser is getting a lot more expensive. It's wasting a lot more memory. We see that in the profiling that only the parsing the created timestamps is taking more than almost half of the memory of the whole Prometheus server. The Prometheus code is also used by OpenTelemetry-Collector. And in the OpenTelemetry-Collector, we see that it's using sometimes almost 3,000% more CPU just to parse the created timestamp. So it's obviously not the best implementation. It's very expensive, and we want to get rid of this. The other problem that we have is this with the suffixes. So the suffix is a must. Depending on the metric type, there are different suffixes. Sometimes some metric types don't have it. For example, gauge, the state set, but most of them have it. If your metric is in units, has a unit, for example, seconds, milliseconds, we also need to add the suffix for the unit to the metric name. So why is this a problem? OpenMetrics was not the first exposition format. We had other formats in the past that didn't require the suffixes. And we had problems when upgrading old implementations to the new implementations. In client Golang, we expose metrics about the Go runtime. And for example, we expose Go memstats alloc bytes, which is the amount of memory that is allocated in the current time. And we have Go memstats alloc bytes total, which is like an increasing count, and a counter that only goes up. It's not the current time, but like the whole time, the whole lifetime of an application is the total amount of allocated bytes. If we go and if we implement this in OpenMetrics, we'll see that the metadata for the gauge is called Go memstats alloc bytes, and the metadata for the counter is also Go memstat alloc bytes. The only difference is the suffix that is not on the metric family name, only in the time series itself. And Prometheus cannot ingest that. This is not compliant with the OpenMetrics specification. This is a new thing. OpenTelemetry was created after OpenMetrics, but we can also see that OpenTelemetry has a hard time translating to OpenMetrics, because in OpenTelemetry, you can have metrics with the same name, as long as they have different metric type or metric unit. So you can see in the right, we have HTTP request duration. One is in milliseconds, the other is in seconds. If we switch and translate to OpenMetrics, the metric family name is the same, HTTP request duration, for both metrics, but the time series has different names. This is also not compliant. It's impossible to translate OpenTelemetry to OpenMetrics 1.0. Okay, so this is the problems that we had in the past when implementing OpenMetrics 1.0. OpenTelemetry also was created not long ago. It's clearly one of the most popular projects in CNCF right now. And OpenTelemetry is creating its own metrics protocol. OpenMetrics, which was supposed to make the Prometheus format popular outside of Prometheus, was clearly not successful, because OpenMetrics created a new one and is getting adopted everywhere, while OpenMetrics 1.0 is not. Another problem that we had is Prometheus created a new format for the histograms. It's more efficient, it's more precise, it's better than the old histograms in almost every single way. And OpenMetrics did not support native histograms at all. And we had a hard time collaborating with the OpenMetrics project maintainers to evolve OpenMetrics to accept a format that we can translate into Prometheus native histograms. You can, if you want to see the QR code for the specification is there, but it's super long. It's worth the read though. Eventually, the OpenMetrics maintainers decided that they would not continue with the project because OpenTelemetry is getting more successful. They didn't have the time that Prometheus needed to evolve the specification with native histograms. So eventually, Prometheus accepted the project as a sub-project. It's now living in the Prometheus organization in GitHub. We also have our own documentation for OpenMetrics. But now, what this means is that Prometheus has the right to evolve the project. We don't depend on OpenMetrics maintainers anymore. We can do the work ourselves. So that's how we got to OpenMetrics 2.0. 2.0 is something that we are working for at least 6 months now. I tend to be too optimistic. I hope we get to finish this in this year, but sometimes things don't go the way I want to. We have a few goals. We want to support native histograms. That's our main goal. We want to address the challenge that we have with created timestamps. We want to resolve this name collision problems with the suffixes, and we want this format to be translatable to OpenTelemetry, so we can collaborate with this new project that's getting very, very popular. So this is the QR code for the proposal that we have with native histograms. It's not looking great in the screen because native histogram is a complex, has a very complex format. We got inspired by the JSON format that we had in the past. We simplified a few things. We removed the headers that the JSON schema usually have. Yeah, if you want to know more about the proposal, please scan the QR code. It's very detailed. Create timestamps, it's such a simple change, but it has such a huge impact. Like instead of creating a new line with the timestamp of the creation, we are just appending to the end of the previous line with a CT at. If the parser, so now that the parser reads a whole line, when we parse a time series, we get the created timestamp of the series at the same time. We don't need to copy anything. Everything is just there for free. Also, we have a proposal. If you're interested, please scan the QR code. Yeah. Next thing, UTF-8. The main goal for the UTF-8 is because OpenTelemetry accepts the whole UTF-8 character set, while Prometheus only accepted digits, American alphabet characters, underscores, and columns. So there's a huge proposal. This is one of the biggest proposals, one of the biggest work that Prometheus had to do. If you see in this example, I have two metrics. One that doesn't have any special UTF-8 characters. It's just the usual format that we always had. But the second metric has this $sign that in the past we couldn't accept this. So if you quote the metric name, Prometheus understands that this has a special character. And the metric name that in the past was before the brackets, it's now inside the brackets. It still has the quotes. The label name also has a quote. And if you expose the metric like this, Prometheus will be able to ingest. Doesn't matter what character you're using. Again, whole proposal is there if you're interested. For the suffixes, we don't have a proposal yet, or we don't understand completely what is the impact. But the idea is that in the specification, wherever it says that we must append a suffix, we're relaxing to should or may append a suffix. Again, this looks like a simple change, but the impact that it has on the whole architecture of Prometheus is like we have so many stuff built on top of the suffixes that it's not that simple. I'm hoping to get this proposal ready this year, implemented this year, but again, things not always go as I want to. For OpenTelemetry compatibility, what I said before, the other features that we're doing with OpenMetrics 2.0, they all benefit OpenTelemetry in some way. Well, for example, the classic histogram format, we could not translate to OpenTelemetry at all. But the native histograms format, it is translatable to OpenTelemetry. So by adopting native histograms, we are also allowing that Prometheus format is translatable to OpenTelemetry. OpenTelemetry requires the whole UTF-8 character set, so we are also working on this. Oh. Okay. When OpenTelemetry users are sending OpenTelemetry metrics to Prometheus, since we require the suffixes, the metrics, when ingested, are appended with the suffixes automatically, and that creates confusion because imagine you are instrumenting your application, you said that your metric is called HTTP requests, and then you go to Prometheus and you query HTTP requests, you don't find anything, like where the hell did my metric go? But actually the metric's there. You should be requiring HTTP request total instead. Like, this is just confusion for no reason. So by relaxing the suffixes, we are removing the barrier for OpenTelemetry users to adopt Prometheus as well. Another thing that we are working on is allowing multiple metrics with the same name, as long as they have a different unit and a different or a different type. This will allow OpenTelemetry metrics to be ingested by Prometheus because of this same requirement. Yeah, so this is the example that I showed before. And that's about it. That's all the changes that we are doing. And if we have any questions, we have 4 minutes for it. The benchmarks?
You showed this slide where there was a flame graph and it showed memory usage because of the timestamp parsing. Do you have a branch where that has been changed and you observed the change in memory usage?
Yeah, so just repeating the question, he's asking if I have a branch with the comparison. I had, but this branch was merged to main. So the code is in main.
Excellent.
Yeah.
Okay.
Yeah.
Cool.
Not the best, but yeah, we introduce a performance degradation, but it's main. I can get you the PR if you want.
Yeah, sounds great. Yeah. Thanks.
I was just curious about the bug that you had in protobuf. Like, there was no workaround around it. Like,
so the problem was in a. So the question is. Sorry, could you repeat the question?
You had a bug in protobuf, so that's why you shifted to text format, right?
Yeah.
So was there no workaround around it because it was efficient, I guess?
So the problem is that the protobuf parsing, we use a library from a third party, and this third party did not develop it, like they just abandoned the project. And migrated from the old library for new ones, it was too much work, and we didn't see any improvements as well. Like nowadays, the bug was fixed, but it took a long time, like 5 years, I think.
Thanks.
Thank you. So I have a question about the format. So you mentioned about the text format for the native histogram, but it's originally implemented as a protocol buffer, I guess. So what is the status of the text format, the current status?
Sorry, could you
sorry. Well, I'm asking about the native histogram format. So it is. I think it is originally implemented as a protocol buffer format, but you mentioned about the text format. So I'm curious about the current situation with the text format for the native histogram.
Yeah. So for native histograms, we have a proposal. I showed the QR code there. The proposal was accepted already. So we are just rewording the proposal to the specification format of EATF, which is like must be like this, should be like that, maybe like this. But the text parser we haven't started yet.
Got it. Thank you.
Yeah. And SDKs, client Python is already implementing. The client Python is where we are doing our POC, the proof of concept. And I think this is the only client that is implementing native histogram text so far. All right, thank you.